So we'll see what is SonarQube. So basically we use SonarQube to analyze our source code. Okay, so it is not for running your test cases. Okay, it is to analyze your source code. But why analyze source code in the first place? What is the use of it? Okay, so code quality is important for overall software quality. Okay, so what is your software? It is basically the final outcome of your build process, right? So in build process, what all things are included? It is your source code and all the dependencies, right? So that makes your final software. So having a good quality software is important if you are planning to release that software into the production. Okay, and quality impacts how safe, secure and reliable your code is, or your final product is. Okay, if your product is not safe to use. Okay, let's imagine you have a website. Okay, so this website is running on HTTP. Okay, so let's say you created an application so that does online transactions, let's say. So if this online transactions application, so if it is running on plain HTTP, so no one is going to use your application, right? So you should secure it with the HTTPS communication. Okay, so what you have to do, so you have to, for your domain, right? Let's say your domain is www.some xyz.com. So for this domain you obtain a domain certificate, right? Understand?
Yes.
Correct. So now
Yeah.
using the certificates, we make our communication secure. So the S indicates it is secure, right? So if you are not, you know using HTTPS, so no, your application is not safe. And it is also has to be secure, using the HTTPS communication, and also reliable. There should not be any bugs or code leaks, memory leaks, like that. Okay, so high quality code is always critical for many development teams today. Okay, since we are following the agile methodology, right? So it is, what is agile methodology? So we don't build our software spending 1 year of time. So instead we take a small, what do you say, we take a set of requirements and we work on those requirements, let's say for a set of 2 weeks, and then we release our software, right? So these are called
Yeah.
sprints, right? So every
Yes.
sprint, or whenever you are creating even a single, let's say, a feature. Okay, so this feature has to be tested then and there itself. Okay, so you should not wait for 1 year till your product is ready, and you should not scan at that time. Okay, so scanning your source code, okay, at every stage of your development is very critical, at least for this generation of projects. Okay, and it is especially important for those developing safety critical systems, let's say your banking applications, okay, or your automation applications. Correct. Understand? So even a small bug can ruin your complete user experience, right? Or it can cause a huge losses. It can bring in huge losses to the company. Okay, and there are many tools in the market that does the static code analysis. Here I am mentioning about static code. Okay, so we were talking about the code analysis, but here suddenly I mentioned static. Okay, so we'll come back to what is the static. Okay, and in all the static code analysis, right? So SonarQube is the most popular one. Okay, and one thing, it is also open source. Other analyzers are also there, so depending upon the your coding language that you choose. So we have analyzer types also. Okay, so we have Veracode, Coverty, Clockwork. Okay, so all these are various tools. But SonarQube, it supports a lot of languages. So at the time of today's recording, there are, I think it supports 27 languages. Okay, understood, guys. So how do you measure the
Yeah.
software quality? Okay, so how do you benchmark your software? Okay, so the code should follow a specific convention. It's not like that, you follow certain convention, someone follows a certain convention. So in this case, what happens is the code becomes highly unmaintainable. Okay, so let's say I wanted to put all the source code in src and all the tests in the, let's say, test folder. While someone comes, he put all the source code at the root of the directory, and the test cases he'll put it in a different directory like this. Okay, so this is not following a specific convention. So if you see maven, so maven we are not calling it as build tool. Okay, we are called it as project management tool, because it also knows how to manage your project. So that's why we have src. Inside src we have main and test directories. Your main code goes into the main directory, test code goes into the test directory. So there is a different project structure maven is following. Okay, similarly the code that you follow you write should follow a specific convention. Okay, and the code should be following established good practices, right? Okay, it should also follow some of the best practices available. Okay, and you should check for potential bugs and performance and security related issues and also vulnerabilities. Okay, so you should scan your source code, and you should make sure that there are no potential security risks involved. That means, let's see, why, how come potential, these risks come in your code. So you might think that I am writing the code, so why will I allow all these bugs into my code? It's not like that. Okay, so when you're writing your code, you are not writing everything from scratch, right? So you are using dependencies. Correct, Maninder?
Yes.
So you are using dependencies. That means these dependencies by are written and maintained by a third person. Okay, so this third person may not be maintaining this dependency for long. Okay, let's say you are using a dependency which was last updated 3 years ago. Okay, then you should know the security risks that are involved in using that dependency. Okay, you should also make sure if there is a possibility, you should completely eliminate this dependency by looking for some other dependency or writing your own dependency. Okay, and you should also make sure that code is not duplicated. Okay, so there is no point in writing x is equal to 7 and x is equal to 7 and in two areas. Okay, so that's why in programming we have so called functions and methods, right? So if you have a reusable task, okay, the task that keeps on repeating, so we create a function for it, and you call functions n number of times. Okay, understood. And also your code should be, should make logical sense. Okay, it should not be too complex. So just because you are a very good developer, it doesn't mean that you should always aim for writing a complex code. Okay, understand? So complex code, see, there are, few things that, having complex code is recommended, but not for everything. Okay, just for addition, I cannot write a very complex code, right? Simple a plus b will also do. Okay, so unnecessarily we should not make our code complex. And does the public api have good documentation and comments? That means the external libraries which are using, so you should also make sure whether it is properly documented, properly maintained. Okay, and also your code should have unit test cases. That is one major requirement. Okay, and also does the code follow good software design and architecture principles? Okay, so this is one thing. So all these things comes under in benchmarking your application. Okay, so now sonar source code analysis. So very simply put, to ensure quality, reliability and maintainability of your software project. Okay, so we do code analysis because a poorly written code is always more expensive to maintain. So why more expensive to maintain is, the first thing is, if the bug is detected in the production, you will have to again go back to the development phase. Okay, what happens? What will happen if these bugs are keep on repeating, keeps coming up some from various parts of your application? Okay, so what if a small bug which was not identified during the development phase, caused a huge losses to your company, right? We cannot have that, right? Okay, so automated code analysis is a powerful and useful technology, and SonarQube is one of the leading open source, code analysis utility, or a software in this particular space. Okay, so according to the official documentation of SonarQube, so SonarQube is an automated code review tool to detect bugs, vulnerabilities, and code smells in your code. Okay, So it detects all these. So whatever things that we are saying, right, like duplication should not be there, vulnerabilities should not be there, right, you should not unnecessarily complex your source code. Okay, all these are identified by your SonarQube. And remember, SonarQube is not responsible for running your test cases. It will not run your test cases for you. You have to run your test cases. Let's say MVN test. So MVN is such utility that is running your test cases, but SonarQube will not do that for you. Okay, SonarQube is not meant for that. Okay, and SonarQube can easily integrate with your existing workflow. That means you can take anything. You take Jenkins, you can integrate with Jenkins. You take Maven, you can integrate with Maven. Okay, so integration is also pretty much possible with the SonarQube. Now we were talking about static code analysis. SonarQube as the static code analysis, right? So what is static code analysis and what is dynamic code analysis? So as the name itself indicate, it is static. That means there are no moving parts. Okay, so what is meaning by that? See, if I take a Maven based application, so basically what will I have? I have a source file and a pom.xml file, and through one build lifecycle called mvn install or mvn package, right? So I can generate a war file. Okay, so for running this war file, what I'm doing, I'm just taking this war file and deploying it to the tomcat container. Correct? Correct,
Yeah.
guys?
Yeah.
So
Yeah.
here your code is static, it is not in the running state. But here your code is running in the tomcat, which is a running state. Okay, so depending upon where you're running your code scans, whether you're running on your source files, it is called static. If you're running on a live application which is already running, which is a dynamic. Okay, so this is the difference. So static analysis is best described as method of debugging your code by examining your source code, okay, before a program is run. That means your source code is there, you have not built your final artifact yet. Okay, so you're just, what you're doing, you're analyzing the source code. Okay, so how do you analyze the source code? Basically you compare your source code and you run some scans using some set of rules. Okay, so you have your source code over here. Okay, so I have a certain set of rules. Okay, so what I'll do, I'll take a rule and I'll run scan on the source code, and I will see whether this rule is violated by your source code. Understood?
So
Yeah.
Similarly,
for a war file, it makes sense, but for Python, it makes you can't tell, right? Static
yeah,
or
no. If see, I'm not talking about war file or any artifact. I'm talking about the running state of your application. That means if you run your Python file, Python web application, your application is running. Okay,
so. I
I'm
mean,
not
so
talking about war file. War file is not the running state. If you run your war file and there is an application running out of it, so that is the running state.
okay. So
Okay,
would that be dynamic or would that be static?
dynamic. See, war file, I cannot run any scans in most cases, because war file is immutable,
Yeah,
right?
yeah,
So you cannot break it, and because it is all binary.
yes.
Sometimes it is bytecode, right? Depending upon the language which you use, either it can be a bytecode or it can be a binary.
So Python
You
based,
cannot break it. And
so
yeah, so
Python.
Python also static analysis. Dynamic analysis means you do it on a running application. Okay, I'm not saying about in case of Maven you run dynamic test cases on war file. I'm saying you run this war file as an app, you run your test cases on the app.
Okay.
Okay, so what is dynamic code analysis? It's the same. So you run your test cases and you find various security risks or vulnerabilities on the live running code. Okay, so that is where dynamic analysis comes into the picture. And yes, SonarQube will not do dynamic code analysis for you. It is a static code analyzer. Okay, understood, guys? Any doubt before going forward?
Vikram, it will detect some, suppose if I have some syntax error or I have some
Yeah. it will detect.
some variable also I have defined, but I haven't used
Yeah.
or I
See,
didn't
let's
didn't
say you have defined a variable, and there is a high chance that that variable might go to infinity value.
Okay,
Okay, so
fine.
there are chances that that variable may overflow. Let's say you
Okay,
declared a variable that can only store 5 and 12. Okay, that's the maximum number it can store. Let's say the system
okay,
detects that it can overflow. Okay, that means it can go 5 and 3. So then that is also a bug.
okay.
Okay, in some
So this
cases you
kind of
declared some
features also I can
variables.
get back.
Yes, absolutely. In
Okay,
case you declared a variable but you are not using it. In case of
okay,
GoLang, what happens is GoLang, when you're trying to build your application or you're compiling, Go automatically removes all the unused variables. So it is called
okay,
automatic garbage collection. But in case of Java or C language, if you declare a variable and not using it, in the compilation stage it might warn you, but it will not compile you to remove it. You can still put it in your source code, I mean your final application. But in case of
okay,
GoLang, it will not allow you. Okay, it will
okay.
automatically remove it. It won't allow you to generate the artifact also in GoLang.
So
Okay.
SonarQube supports multiple languages, right? Code analysis.
Yes, we'll come to it when we go through the official documentation today.
Okay,
Okay.
fine.
Now, what is SonarQube? SonarQube is basically it's a free and open source tool for continuous inspection of your code quality. Okay, and it also helps you to check the quality of your code. Okay, so that means it does the static code analysis. Okay, so basically it covers a wide range of quality parameters or the checkpoints which we call, like the architecture and design errors, complexity, code duplications, coding rules. Okay, so what are these coding rules? Every application will have certain coding rules. Some applications say that you cannot name a variable more than this set of characters. Let's say I cannot use more than 126 characters of a name. People generally don't use it, but these are all coding rules. Let's say a function is there. Okay, so I can have a rule in such a way that a function cannot cross 20 lines of code. Okay, understood, guys.
Yeah.
So these are all rules. Okay, SonarQube comes with the default rules you can write, or you can filter out some rules and create a separate rule base for it. Okay, and it also covers the potential bugs, unit test cases, and code coverage. So this is an important term. Okay, code coverage basically. Okay, so we'll talk about code coverage later. So remember, when someone asks, they might ask you what is your code coverage. Okay, so I'll talk about definition later. Okay, and it does support a lot of language like PHP, Ruby, Java, including your Android, C Sharp, JavaScript, C, C++, Golang. Okay, so all these languages are supported. Okay,
So
and
how do
remember,
you find the rules? Is it like a separate file, like a rule
I'll
file?
yeah, correct. You
Okay.
have to configure it for every application. Sonar provides the default files. Okay, you can
The
also add
default file is dependent on the language.
language. Yes, C you have different file, you different have. So we call it as profiles, quality profiles. Okay, we'll come to it. Okay, so Java will have Java related quality profiles, C will have C related quality profiles. Okay,
Mhm.
understood, guys. So by default SonarQube runs on 1990, or I think it's 9000. So I might have wrongly put over here. We'll see from the configuration also. Default port is 9000. Okay, since your Jenkins is running on 8080, your Nexus is running on 8081, right? 8081. So this is running on 9000. Okay, so they might have decided that already few applications run on 8080 and something, they might have gone for 9000. And like every other the application that we came across, this port is also configurable. Okay, understood, guys.
Yeah.
And you can just pause this video and go through this complete. So basically what this is saying is, so SonarQube can drill down deeper into your source code from module to module, layer by layer, till the classes level, and then it can analyze and give you all such of metrics about your source code. Okay, it also gives you, so if you go to the SonarQube dashboard, right, so you can see where exactly the issues are coming, okay, how to resolve it. Okay, so from where SonarQube took the references. Okay, if you want to fix that piece of bug, okay, so what precautions or what are the next step you should do, everything will be shown in the dashboard. Okay, so let's say that SonarQube found that there is a code duplication. It will clearly identify, it will clearly show you where exactly this is happening, in which line of code, in which file. Okay, so in a beautiful interface it is going to show you. Okay, so we'll come to it, okay, when we do the practicals. Okay, and it integrates with the CI/CD systems like Jenkins, Azure DevOps, or whatever tool you can take, you can integrate with. Okay, so these are the various reports that SonarQube can basically give you. Okay, so code duplications. Okay, if there are any coding standard violations, unit test cases, code coverage. Okay, so I'll talk about code coverage. Okay, and code complexity, potential bugs. Okay, so these are the things it will give you reports. And it integrates with your CI, Maven, and Gradle. So that means the SonarQube scanning you can directly integrate in your Maven. Okay, so how will we integrate? We will see later. So basically, you can have various dependencies created for your SonarQube, and then there are some plugins that we need to install. So if you remember, for Tomcat deployment, we use this, right? So Tomcat 9 colon deploy, right? Correct.
Yes.
Understood, guys. So basically, this is your plugin, and this is your basically a goal. Similarly, for Sonar, we can have something like Sonar colon Sonar. Okay, so this also a command basically used for SonarQube scanning, and this is not the default one. So this came because we have some dependencies and plugins installed. Okay, that means we integrated SonarQube with the Maven. Similarly, in the Jenkins, so we can have Sonar scanner dependency. Okay, included in the Jenkins as a plugin. Okay, you can go to the plugin and then search for SonarQube scanner. There you are. Okay, so you can just download that and integrate with your Jenkins. Okay, similarly, integrations are also possible for all the IDs also, like Eclipse, Visual Studio, IntelliJ for Java. Okay, understood, guys. And
Yeah.
one more thing, so SonarQube can be integrated with your LDAP, so that any user, okay, who are included in that Active Directory can log in into your SonarQube servers. It can integrate with Jira. Okay, so Jira is basically a ticketing tool, right? So let's say SonarQube found one a bug. Okay, so we can configure in such a way that this bug can be created as a, which one, guys? You can create a defect or a ticket in Jira
Jira.
and assign it to someone. Okay, understood. Now they can go to Jira, they can find that this ticket is assigned. And even what you can do in this ticket, right, so you can put a URL. So once they click on this URL, right, so they'll be pointed to the SonarQube dashboard to see why this ticket or defect has been raised. Okay, so where exactly this bug has been found, etc.
So,
Understood.
no, when we do like uh, we build stuff on Jenkins, right? Anytime there's like a webhook which is going to GitHub and it's building automatically,
Hmm. Hmm.
that
Yeah.
would push to SonarQube and SonarQube make its own report every single time.
Yeah, so it's like you are integrating with your workflow. So basically what you are saying, you have the Git repository, you have the Jenkins here, right?
Yeah.
Okay, so when now there is a source code push through Jenkins, through webhook, Jenkins job gets triggered. So inside this job you have to define. So first one, what we are doing, we are cloning, right? And then what we are doing, we are packaging.
Mhm.
Okay, so before packaging your application, so you have to run a Sonar stage, Sonar job. Okay, so
Okay.
you cloned, you scan for all the defects, vulnerabilities, etc. If everything is passed, so that is the check is passed, then you go for packaging your war file, and
You
then you
push.
go to deploy.
You put a condition, right? It has to pass before Maven takes.
Exactly. So if it is passed, then only it will go to the next step. If it is
Okay.
failed, so for failing, okay, so what you can do is you can you can raise an email notification or a Slack notification. Okay, you can also integrate with Jira directly in the Jenkins. I'm talking about in the Jenkins. Okay, so as I said, right, so you can integrate with your workflow. Okay, so whether you're integrating with your Maven, you're integrating with directly with Jenkins, it's up to you. Okay.
So you can, if you don't use Sonar, then basically you would be using Maven test, right? And that's just not as
Yeah.
extensive
So
as
as
Sonar
Maven
test.
test, what you're doing, let's say I have written a sum function which is taking x and y. Okay, so I'm just taking in case of, let's say, Python based function, define some xy, and I'm just, whatever I'm saying is I'm just returning x plus y. Okay,
Mhm.
correct. So now I write a test case. What I write a test case is I call the sum function, okay, with 2 comma 3. I know the 2 comma 3 always return 5. Then I'm checking whether it is equal to 5 or not. I know it is 5. I'll just check if this result when I'm call whether this is 5 and equal to 5. Then this is pass, right?
Mhm.
Yeah.
If it is some 2 comma 3 is equal to 4, so I know it is a fail. It is failed. So till here only we have unit test cases.
Mhm.
Okay, I'm not scanning any external vulnerabilities. I'm not scanning for any duplications here. I'm not scanning if my coding standards are meeting the standard set of rules here. I'm not doing anything. What I'm doing is I'm just running the test cases to see the functions which I have defined are working as expected or not. That's it. That is unit test all about.
So
Okay.
basically,
Okay.
JUnit is to check the logic of the code, right? As they're working
Yeah,
correctly.
JUnit. Yeah, so JUnit is also one such test framework.
Okay.
Okay.
But
So
this
here
SonarQube
they are not.
doesn't check the logic, Vikram.
Sorry.
SonarQube, this analysis is doesn't support any logic test, right?
It will check.
Testing logic.
It will check. Yeah, it will check. No, it will
Oh,
not
it
run
also
your
check
unit
like
test
2 plus
cases.
3.
It will not. Yeah,
Okay.
that's what. It will not check your test cases. Okay, that is with
Okay.
the your test framework. SonarQube is
Okay.
identify whether you're following the standard rules or not. Okay,
Okay.
so you're using a comparison where x I wanted to see whether x is equal to 5. But if you're using x is
Okay.
equal to 5, this is not comparison. This is called assignment. That means I'm
Yeah.
assigning 5 to x. That means x is equal to 5. But here I'm not setting 5 to x. So x can be 4. So 4 equal to 5, it is false. If 5 equal to 5, it is true. But here x is equal to 5 means x is given the value of 5. Okay, let's say in comparison, so somewhere I've used x is equal to 5 for comparison. So this is wrong.
Yeah.
It is x equal to 5. So sonar
Okay.
can cube can detect these kind of errors also.
Okay.
Okay, so that's what I said. So running test cases is not with the SonarQube. SonarQube is to scan the code. Understood, yes?
Okay. Yeah.
Okay, so coming to the architecture. Okay, SonarQube basically has two components. Okay, so we have the web component. Okay, basically you call it as a server. Okay, you call the other one as a client. Okay, so you can call them like that. So what is client, which is your scanner? Okay, what is server? Basically it is a UI which you see all the reports, dashboards, everything. Okay, so why scanner is needed? So you have the source file in your local machine. Okay, this is your local machine. You have the Java related source files. Okay, so you have to install a scanner in your local machine, and then you scan your source files. Understood? Understood,
Yeah.
guys? Then the result of the analysis, it will not be displayed in a local machine, right? So it has to be sent to the server, because it is for the server to process them. Okay, through HTTPS communication it will reach the server, And in the server we have three components. One is the web server. Basically it is responsible for giving the beautiful user interface for the users. We have the compute engine where it will run some test cases analysis. It is like your CPU, central processing unit kind of. Okay. And whatever is the report, right, that your scanner has done or sonar cube has done, so it will go into your database.
So,
Okay, so all the reports are get stored in the database.
so this architecture is the same for any sort of any software, right? This is not SonarQube specific. Like you have this.
Basically it's like if you have Docker, right, so Docker has Docker daemon, which is basically your server, which is, you have client which is your Docker CLI.
Uh-huh.
It's same. So whatever you're saying, right, it's correct, it's same. Everywhere you have the client server model.
Yep.
So in some cases both client and server runs on the same machine, just like a Docker, where we are doing Docker PS, which will show the running containers running. So this Docker PS is a command line command which will ultimately go to your daemon to fetch the information. Okay. But in case of Sonar Cube, right, the server is you will run anywhere like in your AWS or somewhere, right? But these source code in your local machine. Okay, you're sitting in your home, so you have a source code in your machine. So you install a scanner, you scan your source code, you'll send the results back to the server. So server can display them using a web server, process them using the compute engine. Once all the reports are processed, they'll store it in the database. So we have third component called a search server. So why this search server is needed? To speed up your search. Okay, so this database can host hundreds of your reports. Okay, so for searching, for easy searching, so they have something like elastic search. Okay, so this is a search server. Okay, why? From the UI you can search for various reports, then search server can immediately fetch that data and give it back to you. Okay, understood. So this is the database layer. So we have the application layer, web application layer, and this is your client.
So on the client side, that source file's basically sitting in your VS Code, basically, right? And then you just run the analyzer there. Correct.
Not the VS code. You can open it in your IntelliJ or your Eclipse, whatever ID you need, you can use.
But you can
Okay,
use
and
multiple,
coming to
including
hmm,
VS Code. You can use multiple IDs and have the
that's
scanner
fine.
installed
No,
in the same.
scanner is like your you install in your system. Okay, you install scanner in your system. Now, scanner can be invoked from any IDE. You can invoke from the command prompt. You can invoke from the PowerShell, right? You can invoke from the VS Code terminal. It's one and the same, right?
Okay.
And one more thing, this scanner here, right? This
Mhm.
scanner can be installed directly in your machine, local machine. Okay, or through Maven plugins, right? Or Maven dependencies also. You can download in your system. Okay, so in your pom.xml file you can use the sonar dependencies. Okay, and then you can use the sonar cube directly with your Maven utility also. Okay, or else if you are planning to use sonar scanner for a lot more projects, right, for
Mhm.
GoLang, Python, everything, you can directly download in your system only. Understood?
Okay. But for Golang, you don't need it, right? Because it automatically is going to delete everything which is not required, right?
Now, that is only till the variables. Wait till the variables. But
Okay.
what about finding the security risks, vulnerabilities, all such stuff?
Okay.
Okay. So Sonar scan, it is a scanning utility. So it is not only for removing the unused variables. It is not as simple as that. Okay.
Okay.
Now we said that we have a scanner, okay, and the centralized server. SonarQube server can be installed either as a standalone application or as a Docker container. If you remember Nexus, we just downloaded the tar file and we ran the Nexus, right, from the bin directory. Correct. Similarly, SonarQube also can be installed basically as a standalone application, or it can run also Docker container. Okay, so basically we run it using Docker container. Okay, so that is the ideal choice. Okay, And now by default, SonarQube will use embedded H2 database. Again, this is an important question. Okay, so whatever is the database that you're seeing here, right? So by default, SonarQube will use the H2 database, which is basically internally available. Okay, so you should not use the internally available H2 database if you are planning to install SonarQube for your production requirements. Okay, so inside production requirement, what we will do? So we'll create an external database. Either use psql to create a database. You can run it as a database container or a standalone application. It is up to you. And have your Sonar configured to talk to this Postgres. Okay, so let's say you have MySQL. Okay, so this also, you set up a MySQL container or an application and have SonarQube talk to this MySQL. Similarly, if you have any other database service in the AWS also we have, right? Correct.
Yes.
Hello. So we have the
Yeah.
database services. We'll come to it. So you can set up a
Okay.
database there, and then you can have the SonarQube use that database. Okay, so internal database, you should not use if you're planning for production. Okay, so you should set up an external database and have your Sonar configure to talk to that database. Okay, in this demo we are going to see, okay, both h2 as well as the h2. We don't have to do anything, it will automatically using it, but Postgres we'll see it. Okay, so as I said, Sonar scanner, you can directly download it. So here, so don't get confused with this server and scanner. Okay, scanner resides in your local machine. Server is one which everyone is going to see, going to use, so it has a UI, etc. Okay, so Sonar Scanner, you can directly download it in your local machine. If you extract it, right, so you have a bin directory here. So inside this bin directory, you have the Sonar Scanner utility. Okay, so let's say you have the pom.xml file or Maven related application. So using this utility, you can scan it locally. Okay, so reports are generated here. So now in order to push it, so where do we push it? From your local machine to server. Okay, understood, guys? Okay, so basically once you install this Sonar scanner, right? Okay, so there is a server component. Okay, so where the server is running some URL. That means it is running on IP, some port combination. Okay, so when Sonar scanner is done with the running the source code scan over here, so where does it push to? Okay, it needs this URL information, authentication information, etc. So where do we configure them is, so inside this configuration file, so we have something known as Sonar scanner dot properties file. Okay, so in this file, basically what you will do, you will use this sonar host.url and change the URL. Okay, so basically if you're running SonarQube locally, it will be local host, or this will be your EC2 IP. Correct.
Yes.
Correct, guys.
Yeah.
Yeah, so how do you invoke this SonarQube? Basically is inside this directory there is a file called sonar hyphen scanner. Okay, understood, Maninder? So invoking the sonar-scanner, I can go to this bin directory and invoke sonar-scanner. But if I have to do it from anywhere, right? So what I'll do, I'll take this path location of bin and I will add it to my original path, right? So like this, okay, export path is equal to, so dollar path, okay, colon, whatever is the location of your Skona scan directory slash bin. Understood, guys? So now whatever binary is existing in this bin directory can be invoked from anywhere. Okay, so that's why we have to export the path, so which is already existing path colon, so wherever you unzip your Sonar scanner slash bin. Okay, so now I can run Sonar scanner from anywhere. If you want to see the version, it is Sonar scanner hyphen version. That's it. Understood?
Yes.
Okay, so this is how you configure your Sonar. Yeah, and one more thing. Okay, so we said that Sonar a scanner is for scanning your projects, right? But for scanning your project, SonarQube also needs some information. Sonar scanner. Okay, so this Sonar scanner once successfully installed, so wherever is your source code, right? So we have the Maven based project, so we have the SRC, we have the pom.xml file. So once you run mvn package or something, so you have the target folder created over here. Correct, Maninder?
Yeah.
Now, so in the same location, right, in order to for the sonar scanner to scan your project, so you should have the sonar hyphen project dot properties. Okay, so scanner dot properties is for the scanner to talk to your central server, but here this sonar project properties is for the project related properties. Okay, what is the project key? Okay, what is the project name? So all these information basically will set in the SonarQube server. Okay, and what is the version of your project? What is your encoding, whether it is UTF-8 or any other encoding? And where are your source files? So the dot indicates the source files are in the current same directory. So this properties file is also in the same directory. So source files are also in the same property, same directory. That's why there is dot. Okay, so now once this configuration is there, so you can run sonar scanner. You can invoke the sonar scanner utility. So what the sonar scanner do is it will run your source file. So we have the src pom and this sonar hyphen project dot properties, right? So it will analyze all your source code, and then it will try to push it to the server. So server details already sonar scan knows from where, from the sonar properties. And then if it wants to send those reports back to the server, then so where exactly it should send. Okay, so which project, what is this project name? Okay, so every information is there. But when I wanted to push it to the remote server, I need the authentication token. I cannot use the username and password, right? Correct.
Yes.
I need the authentication token. So I create a token. Using that token only, I'll send the reports. Understood, guys?
Yeah.
Yeah.
So Sonar
Okay.
Scanner has its own properties, and then the Sonar itself
Yeah.
has a properties, right? There's
Correct.
two.
So I'll explain one more time. So this is basically your server. The server is running on some IP port. Okay. So this is your local machine. Okay. So inside this local machine, we have the Sonar scanner installed. Okay, so this sonar scanner has a properties which is sonar hyphen scanner dot properties. So what these properties will do, this sonar scanner properties will have the details of your remote server, which is basically your IP port, all the authentication information. Now you have a project. Okay, so which is a maven based project. So we have the pom and src. Similarly, there could be another maven based project. We have the pom.xml and src. Okay, so for each related project, so we'll create a another equivalent project in the sonar server. So from here we'll get the project key and project name. Okay, so for every project there is something known as sonar hyphen project dot properties. Okay, so here what we'll have, you have the project key, project name, okay, encoding, etc. Okay, so this information. So now when sonar scanner wants to scan it, so simply we have to invoke sonar hyphen scanner, and we can pass some environment variables like what is the authentication token. Okay, so once you pass the authentication token, right, so the scanner will run your source scanning on these source files. Okay, and then it will try to send it to server. So server details are available in the scanner. Okay, but where exactly it should put those details for which project? So when your project key and name, so those details are in here, which is sonar project properties. Server related we have with the scanner, project related we have in the project properties file. Okay,
Yep.
understood, guys?
Yep.
So if you see sonar hyphen project dot properties in any of your maven or of any project, remember, think that so that is being scanned using SonarQube. Okay, so that's why if you are integrating SonarQube, so for every project, right, there should be a sonar properties file in your project. Then only sonar scanner can, excuse me, sonar scanner can scan it. Okay.
Vikram, so for this SonarQube code analysis in Maven applications, so we need to mention any plugin inside the pom.xml.
Yes, exactly, because sonar is not a default life cycle, right?
Yeah.
So we
Okay,
have
fine.
to extend, like Tomcat also we have done it, right? We install
Yeah,
Tomcat plugin.
yeah.
Sonar also, we use Sonar plugin.
Okay.
Okay. So now let's understand, this is the final topic. So let's understand what is code coverage, quality profiles, and quality gates. So these are, very important in from the interview perspective. Okay. So what is
Yes.
code coverage? Okay. So code coverage is a metric that can help us to understand how much of your source code is tested. So what is the meaning of how much of source code is tested? Okay. So let's say I have 100 lines of my source code, but whatever are the unit test cases which I have written, okay, they only cover only 50 lines. Okay, understood. That means my code coverage is only 50 percentage. That means someone wrote limited test cases. Okay, one example, let's say I have an if condition. Okay, if x is greater than 7. Okay, so what I'm saying is I'm just saying print something greater or some value. Okay, else what I'm saying, just print uh, small lesser or anything. Okay, some if else condition. Now when I'm writing the unit test cases, so what I did is, so I just tested by putting x is equal to 8. Okay, understood. That means
Yeah,
the test cases ran here. So 8 is greater than 7 and the test is passed, and that means the test is covered only till this part.
yeah,
Okay, so I never have any unit test case to test whether x is less than that 7. If x is 6, then it will always go to else. Okay, let's say I have a test case only x is equal to 8 and the test case is passed because this is true. I've never checked the else condition, okay, because I never felt the need of it. Then what is happening here? So you're only covering 50% of your code through the unit test cases. If I also have x is equal to 6 or 4 or something that also covers the else part, then that is 100% code coverage. Understood?
yeah,
Okay, x, not putting x is equal to 4 is not a defect. Okay, it's just that I'm not testing the else part. Okay, so this is the code coverage. The code coverage means, let's say you have a source code and you have a test suite. So how much percentage of your code is covered under the test suite? Okay, that means if you are covering only 90% of the code. Okay, and one more scenario. So there might come a situation where writing a unit test case for a particular logic is difficult for you. Okay, so in some cases you will not be able to write a unit test case for that particular piece of logic. Then in that case you will stop from releasing the software to the production. You can't do it, right? Understood, guys?
yes,
So there is always a trade off. Okay, so it's not like you have to cover 100% of the code. Okay, so you should what do you say, aim for anywhere some from 80 to 90, 95. That is also fine. Okay, for example, if you have 90% code coverage, that means 10% of your code is not covered under the test cases. Understood? Okay,
yes,
so how your code coverage is basically calculated? Okay, so I'm saying it as 80, 90. So what are the different scenarios that get analyzed when you're doing code coverage? Okay, first is function coverage. Okay, let's say I have a sum function, multiplier function, addition. Okay, sorry, subtraction. Some functions are there, but I'm testing only addition function. I'm leaving all the other functions. So that is function coverage. What is statement coverage? Statement coverage means we have if else loops. Okay, or let's say, so there are some statements, okay, which are never executed. Okay, so imagine I have some let's say uh, okay, so I'm saying if x is greater than 7, let's something, I'm just doing exit here, exit with negative code, and here I'm declaring x is equal to 7, let's say. Okay, understood. So if x is greater than 7, the next statement is exit. That means control will automatically exit from this location or from this point. So this x is equal to 7 is not reachable. No matter whatever you do in your source code, this statement is never reachable. If x is less than 7, it might go to the else condition, but it won't come here, right? Understand?
Yes. Yes.
Yes.
Correct.
Yes.
So this statement, even if it is there, you will not be able to reach it. So that is statement coverage. Okay, if you have any such statements, you have to remove it. Then branches coverage. Okay, how many branches of your control structures are done? That means if you have if else, so whether you're covering else also or not. Condition coverage. Okay, so you have true or false conditions. So you are just checking only true conditions, you are not checking false conditions. So that is condition coverage. So lines coverage, how many lines of your code has been analyzed, how many of them are not able to reach or not analyzed. So all these are considered, and a final code coverage percentage will be calculated. So that is called, we have code coverage. So for code coverage, right, so we have a lot of tools. For Java we have Kobechura, Jacoco plugin. So these are all plugins that can be integrated with your Maven. Okay. So as I said, so these plugins, right? So either they can be installed as a small application, or directly they can be installed as a plugin using your Maven. Okay. Understood, guys. So for Python also we have, Ruby also we have. Okay, these are all code. So how much percentage of code coverage you should aim for? So it is generally accepted that 80% is good, if not ideal for production release, but anything greater than 80 is always good. Okay, and at the same time you should not aim for more core coverage at the beginning of the project, because instead of writing a source code, you'll end up writing the unit test cases unnecessarily. Understand? So what is this code coverage is all about? Testing it, how much test that your test suite is covering your source code. So if I am writing from some function, at the same time I'll write the same unit test case for that function. Okay, if I keep doing it initially, so it's a lot of time waste, right? So initially at the beginning of the project you should not aim for more core coverage, but ultimately at the end of the nearing your project end, or at the release stage, right before the release stage, you should always make sure that you reach to the minimum acceptable level. Okay, then what are quality profiles? So this code coverage, quality profile, and quality gates are very important terminologies. What are quality profiles are? These are set of rules. Okay, so you are asking about rules for C language, rules for Java, right, Maninder?
Yeah.
So this is a profile. So this profile will have set of rules. For Java there is a Java profile, for C there is a C profile. Okay, so every language will have a default profile. So we call it as Sonar way. Okay, remember the name, which is Sonar way. Basically Sonar itself is providing the most commonly used rules, and they are giving it as the Sonar way profile for every language. For C there is a Sonar way C profile. For Java we have SonarWay Java profile. And for in majority of situations, right, so this is the standard and most recommended one. Okay, you can also create your own quality profile. Okay, so that is also there. Understood? Then what are quality gates? Okay, so what are quality gates is, so let's say it is just like a gate. Okay, so it is just like your gate. Okay, at one side you have your source code, at the other end you have the production environment. Okay, so you have your source code tested, you ran your static code analysis, and these analysis is failed. Okay, or you you said that in order to release my software to the production, there should be at least 80% of you know code coverage, there should not be any new issues, some rules you have defined. But when you're running your source code, so you found that your code coverage is only 77, and there is one new issue. Then what you say? So you fail this quality gate. That means the gates are closed for production. That means you cannot release that piece of code into production. So now when this quality gate is passed. So the quality gate is passed in these scenarios when you have code coverage greater than 80 or there are no new issues. Then you open the gates. So open the gates in the sense your software is ready to be deployed in the production. So this is called as a quality gate. Okay, so basically we have three gates. One is pass, where the quality QC means quality gate metrics are met and production can continue. We have one, barely met, that means some are met and some are not met, so should be verified. That means if you feel that some of the issues are tolerable, okay, they don't create any major issues, then you can go for production. But if the quality gate is fail, right, you should not release that piece of software into the production. Understood, guys?
Yeah, so it's like if it doesn't pass, then the
You will
DevOps
not go to the deployment.
DevOps
So you
person goes
said
back
right,
to
the
the developer.
Tomcat. Sorry.
So DevOps person goes back to the developer and asks them to write more test cases.
No. So it's an automated process, right? If the quality gate is failed, so you yourself can configure the notifications that are sent to the developer directly, or else you can also share that report or inform them via URL. So if you give that URL to them directly, they'll click that URL and find all the issues.
So then they would submit everything back in GitHub.
Yeah, again they'll go back to the development, they'll again create a new commit that will again trigger the Jenkins job, does the call ticket checking again, like that.
Okay.
Okay. Yeah, so we'll now go to the setup. Okay, so we'll take at least 20 minutes. Okay, so first thing is I'll start creating an instance. So for SonarQube also we need T2 medium. Okay, so remember you should shut down your machine once you're done. So T2 medium I'm using. Configure details, it's fine. Add storage 8 GB is fine. Security group. Okay, in the security group I am just adding one rule, which is basically 9,000. Okay, so you can do one thing, you can just allow all traffic or you can just allow 9,000 port, because 9,000 is what your sonar queue will be using, but we'll not be accessing it for now. Okay, so let's just put all TCP, review and launch. Okay, so while it is launching, okay, so let's go to the view instances. What is this? This is, why this is disappearing. Okay, so let it run. So we'll go to the official documentation, which is basically SonarQube. It is sonarcube.org. Okay, so you can go through. See, this is quality kit. So one which they are showing right in the UI. Okay, so this is code quality and code security tool. And now if you see here, it is able to give you all such details. It is saying a null pointer exception could be thrown. Okay, so it is saying it could be thrown. Okay, and then see the quality gate here, it is passed. That means there are zero bugs, zero vulnerabilities. Okay, one hotspot, four code smells. Okay, 5 minute technical depth, that means these are all tolerable. Okay, so having four code smells or 5 minutes of technical debt, okay, I will talk about that later. Okay, these are tolerable. Okay, so these are okay for the current release, so the quality gate is passed. Understood. So for as of now, there are 29 programming languages supported. So these are all the languages supported. You can easily integrate with your CI/CD. Okay, and you can also give feedback during the code review by integrating with all these repositories. Okay, so these are all the various things. And coming to the editions, so we have the community edition, which is basically free and open source. Okay, we have the paid versions, basically developer, enterprise and data center, where the number of rules that your sonar cube will process, or the features will be different. Okay, so it might offer the maximum benefits. But in community edition, so it is good for a small set of projects. Okay, understood. So I'll just go to the, and the current version is sonar 9.3. Okay, you should also remember the versions. Okay, and now code will go to the documentation. Okay, so this is the SonarQube documentation, and if you want to try quickly, so you can just click on this try out SonarQube. Okay, so I'm just closing it. So the same can be found here in the official documentation. Try out SonarQube. So there are two ways you can set up your server. Okay, so from the zip file and from the Docker image. Okay, so anywhere you can set up. So in this lesson, we are going to see how to download the zip file and how to run it. Okay, yeah, so this is it. So coming to the requirement, so there are some prerequisites. So the prerequisites are we need at least 2 GB RAM of RAM to run and 1 GB of free RAM. So that's why we went for T2 medium. And one such prerequisite is you need to have Java 11 as the prerequisite. So you need to have Java 11, and uh, you can use OpenJDK 11. And coming to the external databases, Postgres 13 is supported. Microsoft SQL Server 2019 is supported. So Oracle also is supported. On the browsers, these are all the supported browsers. And on the platforms and Linux platforms, you should make sure that you put everything. Okay, so um, you know you should put all these parameters. Okay, so vm.max map count. So even I'm not so sure about all this. Okay, so these commands you have to run basically. Okay, and yeah, so these are all the various things. And set up and upgrade, so you can just click on this overview to install the server. So this is basically the diagram which we already seen. Okay, understood guys?
Yeah.
Okay, so
So
we'll see about installing the server component first. Sorry.
when you use it with Docker, right, do you still need to export path and do all that stuff with the Docker?
Export path, which one?
Yeah, when you when you download it with Docker image, right? When you
Mm-hmm.
run it container, um,
Mm-hmm.
you still need to do the path association with that
No,
as
no,
well.
it's not needed. No, it's not
You
needed,
with the server, right? With the
because
actual
it
thing.
will be there in the actual Docker container. You don't have to set the path.
Okay.
Okay, now coming to the installation of server. Okay, so coming to the other quality profiles and all, right? So in the analyzing source code, you can see about scanners, test coverage and execution. Okay, so you can go through the complete documentation once. Okay, so test coverage. Okay, so we have Jacoco plugin. Okay, you can go through it. So basically you have to go through all of these just once. And then coming to the user guide, you can go through quality gates. So what are quality gates? Okay, so what is pass, fail, and all. And next, you also have quality profiles, instance administration. So here it is quality profiles, how to create a new quality profile. So you have to go through all of them at least, once. Okay, so now I'm going back to setup and upgrade in the install the server part. Okay, so for the server installation, okay, so as I said, right, you can use the internal history database or you can go for external Postgres database. So the first thing is you download SonarQube from the zip file. Okay, if you click on the requirements, so it will show you the Java 11 requirement and all. So this requirement will fulfill, which is using Java 11, at the same time taking the T2 medium instance, and unzipping the distribution. So how do you download? So basically you click on this distribution, so it will take you back to the download space. Okay, and now once it is downloaded, so what it is saying, SonarQube cannot be run as root. So if you remember in Nexus, we created Nexus user, right?
Yes.
Correct. So similarly for
Yes.
SonarQube also, we cannot run it as easy to user or root. So we have to create a user of its own, and then you have to run it. Okay. So let's say you unzip this folder somewhere, and I'm calling that unzip directory as SonarQube hyphen home. So somewhere I extracted. It can be you slash opt or anywhere. Okay, so now once this is done, right, so in order to run it directly, so you can just, okay, run. Okay, so if it is extracted somewhere, right, so in that bin directory, Okay, you have for various operating system. For Linux there is a Linux folder, for Mac there is a Mac folder, and for Windows folder. So inside it there is a sonar.sh file. Okay, you have to run it, and then you have to give an argument as a start, stop, status. Okay, start, stop to stop, and status to get the status. Similarly for Mac OS it also uses the sh script. For Windows it is the batch script .bat file. Okay, and see, once you run it, so basically you can access your SonarQube on 9000 port. Okay, basically it will be your EC2 IP colon the port number, and the user credentials also shown here, admin/admin. Admin is the user, password is also admin. Okay, so far so good. Okay, so we use the internal history database, but what if I need to use external database? So for external database I have to set up an external DB. So once DB is created, so I have to configure those DB details in the configuration folder of Sonar installation directory. So there is a file called sonar.properties. So inside this one, so I have to configure the database details, and I have to restart my SonarQube so that it uses the new database. Okay, any confusion, guys? Okay, and coming to the Docker, so they gave how to run the Docker also. So this I'm not covering. Okay, so there is also a docker compose.yaml file. Okay, and one thing about this docker compose file, right? Okay, so there is a full example. So what is this full example is, we have the SonarQube server. At the same time they gave the database also, which is Postgres. Okay, so that means they are not asking you to set up the external internal, use the internal database. So they're directly giving the complete setup of Docker. Okay, so I want you guys to test this.
Okay.
Okay, so they are using the
Yeah.
12. Basically if I just go back to the supported databases, it is the latest one is 13, but 12 is also good. So you can just run this complete docker compose file to set up your sonar server with the Postgres database. But this is easy, right? But I'll show you the tough way, which is doing it from the zip file.